Hey class, welcome back. If you check it out, it's Monday morning and we're going to go through some of the current events and mainly what we're talking about this week. We've been kind of walking through all the 6 kingdoms of life. We're spending a little bit more time with fungus, and in particular we're talking about mushrooms. If you can get your hand on a mushroom this week to check out, that would be great. If not, we've got some diagrams that we'll have online, and also there's one behind me on the board here. So check those out for yourself. Start with current events today. If you check out the current events, we're talking about Memorial Weekend coming up. It's been tough, I know, on all of us doing the social distancing and sheltering in place. It's important to remember, however, that this virus doesn't move itself. People move it from place to place, continent to continent, all over the place. And when we're doing the sheltering in place and all the social distancing, it's important to keep that going for just a little while longer. I know it's been tough on my family and all of us, really. I sure miss having everyone in the classroom here. But especially as we kind of come to the home stretch here in California with some of the sheltering in place, it looks like for now, just kind of keep in mind that that's what moves the virus around, is the really close contacts. That's where we're wearing the masks and everything. If you check out something they mentioned on CNN News, I just threw it up here on the board for fun. Around the corner from where I am right now, really, you're pretty close here. What used to be, years ago, the Burlingame Drive-In. Now, it doesn't exist anymore. It's been long gone. But a drive-in, a place to see a movie where you pull in your car and you watch the movie on a big screen, and there's a little speaker up on the window. I remember when I was a little kid with my family, we went and saw the movie Jaws here at the Burlingame Drive-In. We were all sitting there in the theater, well, the drive-in theater, watching it with the sound speaker on the window. Apparently, with the social distancing going on right now, those are kind of making a comeback. Although I imagine they're using cell phones and things for that now. Okay, jumping into fungi, doing a little recap on fungi. Get it? Recap. There's a cap right there. Sorry, but the jokes are even worse in an empty classroom. There's no one here to groan about them. But the recap. We're going to use mushrooms as our kind of our base for understanding a little bit about the fungi kingdom. Fungi are interesting. You could spend a whole semester talking about fungus and their variations. And we tend to think of them as being kind of like little plants, but they're actually probably closer to people, both genetically and just in the way they get their food. First of all, this picture right here. Notice there's no green in it. That's on purpose, just because when I was sketching this here, wanted to make sure I didn't use any green because they don't have any chlorophyll. They are not autotrophs. They are heterotrophs. They eat for a living. I've heard it compared to this. Imagine if you were at a birthday party and you wanted some birthday cake and you ate like a mushroom. You wouldn't just consume the birthday cake. You would use your hyphae. You think about it, if your fingers were like the hyphae, the part of this that we're going to talk about in a second. You would reach over and you would touch the thing that you're going to eat. You would secrete an enzyme. We've talked about enzymes before. They can break things down. That's one of their jobs. Enzyme would then break down the food and then you would absorb it that way. Sounds like something out of science fiction, but when you look at mushrooms and you look at fungi, they're much more closely related to animals than they are to plants, which is kind of interesting. Quick recap also on last week, some of the things that we talked about that they're important for. Bread and food in general. If you go through your supermarket, most of the things that you see, at some point in their production, they were made either with fungi or they are fungus. You're buying a fungus directly. Chocolate, one of my personal favorites. If you check out chocolate, the bitterness of chocolate is made less bitter through the fermentation process. We know from last week, fermentation, for example, the wine industry here in California, depends on the fermentation process, depends on yeast turning sugars into alcohol and usually releasing some gases in the process there. Recycling is up there. When we talk about recycling, we're not talking about the things that you put into the blue containers around campus, although that's important. We're talking about, for example, fall. In the autumn and the fall, hopefully when we're all back in the classroom in person, obviously the leaves, it gets the name fall because the leaves are falling off the trees in general for deciduous trees. Why aren't we, neck deep in leaves from year after year after year of this happening? Well, mainly because if you check out fall, those leaves on the ground, fungus go to work decomposing those very, very quickly. The fallen logs, the leaves that fall down, they recycle that material, they put it back into the soil, they put the nutrients back in the soil so other trees and living things can use it. Medicine, if you look at medicine, we talked a little bit about Fleming and his accidental discovery of penicillin, an important application of one of the antibiotic properties of some fungi. And if you also look at what we studied this year in your social studies class, when I talked about ancient Egypt, there's even old texts from ancient Egypt that talk about eating food, eating bread in a spoiled state as a remedy for some diseases. Now, they didn't know this, but they were probably eating the penicillin fungus, and it was helping, they realized, with certain afflictions, certain diseases. So they had kind of stumbled upon penicillin themselves, we think. Also, it's not all amazing recycling. Some fungi are parasitic. There are some really weird parasitic fungi out there. For example, there's one that can attach itself to a living insect, and the insect will leave its colony, usually an ant. It'll crawl to a high spot where the parasitic fungus will literally consume the insect. It'll send up a fruiting body and send out spores, which we'll talk about here in a second. But it's a very strange alien thing. Something more down to earth, athlete's foot. It's caused by a fungus that literally grows in a moist environment, usually from things like if you've been on a swimming pool or something like that. So here's the practical part of the class today. When you get to high school and you're using like the swimming pool in high school or something like that, or this summer, wear sandals. And again, keep your feet dry. It's going to sound really silly. Use a blow dryer. Blow dry your feet, and you won't get athlete's foot. So there's your handy, practical upshot of learning all this stuff. If you check out this picture right here, this fungus, this particular thing, when we think about eating a fungus, eating a mushroom, what you're really eating on a fungus is just the very, very, very tip. It's called the fruiting body. It's the one that produces spores. Now over there, I've got the vocabulary for the week. Our job today, like I usually start when we start like a new thing that we're studying, is we have a little bit of vocabulary that we want to make sure that we take the time, sit down with a dictionary, or nowadays is Googling things, I know, but just check out a quick definition in your own words. One of these is spores. A spore you can think of for now as a seed. When you're looking at a mushroom, say on a forest floor, or a mushroom in a supermarket, its entire job, the reason that it's got that shape, the form follows function. One of the things I'd like you to look for on the diagram, or look for if you happen to have a mushroom of your own, is the underneath side, these little gills right here. These gills, they look like gills like you'd see on a fish. They're very, very close structures that come around the stalk, and they produce spores. The number of spores produced by a single fungus is absolutely stunning. I drew a little puffball here, which is not related directly to this fungus, but a puffball, you've seen them probably before. I know some of you came across them down at Outdoor Ed, and it's just what it sounds like. It's a small fungus, grows on the forest floor usually. If you squeeze it, it looks like a little puff comes out of it. That little puff, all those little particles that you're seeing as it comes out, it looks like dust. It's really, really, really fine. Are the spores that this fungus has produced. The stunning number of spores they produce. I had heard the calculation several times that if you just took one puffball and every single one of those spores was allowed perfect conditions to reproduce and make its own puffball, and only 2 generations for the average size puffball, every single one of those spores was allowed to grow to full size, you would have a weight equivalent to the planet Earth. That's one, how many they produce. And 2, it shows you a little something about how nature works with the tremendous overproduction of seeds and spores. Very, very, very few make it to maturity. So they produce a tremendous number of seeds and spores out there, hoping that one of them will land and get just the right conditions to reproduce. If you check out evolution, I said this is where the science steps in. The reason I like to point that out all the time is, remember, the things that you see in your science book are not the end-all be-all in science. Science is not your science book, and in our case, I'm always trying to point out that this is an ongoing process. We're pretty sure bacteria and archaebacteria, were the first to evolve on the planet. There's even a little bit of debate as to which of these came first. As you can imagine, the fossil record going back past 3 billion years is a little spotty. And one of the things that we've studied in this class is DNA, deoxyribonucleic acid, the molecule of life it's been called. That's really, really important because when you look at DNA, it gives us a much better feel for how we categorize things into separate species and when diverged on their evolutionary path. These first three right here, the bacteria, archaea, or archaebacteria, and the protists, we're pretty confident that these were the first three kingdoms that evolved. When you get up to plants, animals, and fungi, or fungus, it gets a little fuzzier sometimes. Again, the fossil record is not entirely clear, but the important part to remember is that animals and fungi are much more similar than animals and plants. Plants are what we call autotrophs. Remember good old photosynthesis. We'll be coming back to that again and again. They make their own food. Animals and fungi are heterotrophs. They eat other things. And if you're looking at our vocabulary for this week, we have autotrophs and heterotrophs up there. Make sure you check that out. Just gave you the definition right there. Parasite, again, we talked about some fungi as being parasitic. They're not the only things in the kingdoms of life that are parasitic, of course. But in the case of fungi, some are beneficial to humans, others feed off of humans or other living things. As a matter of fact, when you look at the way that we divide up fungus, one of the very first ways we divide it is some fungus lives solely on dead organic material. Remember, organic material, things that contain carbon. If you look at the other category of fungus, they actually make their living on living things. Going through a couple of more up here, we'll spend time with these next three terms: gamete, haploid, and diploid. It just has to do with reproduction. It has to do with circling back to how we talked about different species mix their genes together within a species, I should say. How they mix their genes and how we have sexual reproduction that makes for a tremendous variety of life. And then finally, a germ cell, again, that goes along with haploid and diploid. And fermentation, we talked a little bit about already. Finally, when we're looking at the fruiting body right here on a mushroom, there's a huge variety of them, but the main point is that the underground hyphae, these long tendrils that spread out in the ground, when you look at a mushroom, what you're only seeing is just the very, very, very tip of a fungus. The rest of it, the vast biomass of it, is underground. It's sending out these hyphae, these tendrils, if you will. They call this the mycelium. It's like a network of tendrils that go out, and it's pulling nutrients. It's digesting the nutrients with an enzyme and then pulling the nutrients back up. We'll talk about how those nutrients get incorporated into the rest of the fungus, but we've got our vocabulary to work on this week. And again, this diagram will be in our notes as well, and we're looking in particular at how they reproduce and how they get their nutrition and how they're different from plants. We're going to do the classic Venn diagram. You've seen those two big circles. You have plants in one circle, fungus in the other circle. Where do they overlap and where do they diverge? How are they the same? How are they different? That's our little overview for fungi for the week, and hope to see you back in class again soon. Take care. Bye-bye.